I'm going to show you an example of a limiting reactant problem that deals with solution stoichiometry. This is sort of a mix between solution stoichiometry as well as traditional stoichiometry, where you're going from grams to moles to grams. In this case, I'm going to ask you a question about limiting reactant. So I have a specific volume and concentration of magnesium chloride and a specific volume and concentration of sodium hydroxide. And when these two are mixed together, a solid precipitate will form, magnesium hydroxide and sodium chloride aqueous. So to start this problem, you really need to figure out how many moles of both of the reactants that you have. The way you do that is traditionally just molarity times volume. And you always start with the volume, and you always have to think of molarities as unit conversions. So they convert between moles of solute and volume. And I've set this up where I have my 100 milliliters of magnesium chloride times its molarity. So this is really volume times molarity. And that will tell you the moles of magnesium chloride, because this will cancel out. Now it becomes a traditional problem with stoichiometry. And my goal is to figure out the mass of magnesium hydroxide that's formed. So what I do is I'd look at my balanced chemical equation and say for every 1 mole of magnesium chloride, I'm going to make 1 mole of magnesium hydroxide. And I don't want to know the moles of magnesium hydroxide. I want to know the mass. So I'm going to multiply this by the molar mass of magnesium hydroxide for every 1 mole. And that will cancel out. So I'll be left with grams. And I've done that math already. It's 2.92 grams of magnesium hydroxide. That would be the problem if I would be done if I asked you a problem if I'm going to mix magnesium chloride, 100 milliliters of 0.5, and an excess of this. But I don't have an excess, I have a limited amount. So what I need to do is the same thing, my volume times my molarity to give me moles of sodium hydroxide. And I have to do the same thing. I have to convert to magnesium hydroxide. Now you'll notice that it's not a 1-to-1 ratio in this case because there's a 2 in front of this balanced equation. But my moles cancel. And then I have to do the same thing, 58.33 grams of magnesium hydroxide for every 1 mole of magnesium hydroxide. And those cancel. When I do that math out, I get 1.75 grams. So if I were to take 150 milliliters of 0.4 molar sodium hydroxide and mix it with an excess of this, I'd produce 1.75. But I don't have an excess of either of these. So when I'm doing a limiting reactant problem, whatever yield I come up with, the mass of the magnesium hydroxide that's the lower number, this is what we call the theoretical yield. And remember, the theoretical yield is always produced by the limiting reactant. So the biggest point here is that you can get yourself into moles by taking the volume times the molarity in this first step, because this is the same thing as the volume times the molarity. And then once we have moles, then we can do traditional stoichiometry to get to grams of the product. So that was my goal, is to figure out how many grams of this, once I mix these two things together, that could potentially precipitate out. 1.75 grams is the maximum that can be produced.